So, hi guys, we are going to understand a few set operations, and we know that the sets can be um, represented in different ways. But one of the most common ways of representing a set is in the roster form. So let's consider two sets, right? A set A and a set B. And of course, in the roster form is essentially the way of listing down all the elements of the set. Okay. So when we list down the elements of the set, we use these curly braces and we write down the elements of the set separated by these small structures called commas. So these are the punctuation marks, right? To separate one element from another element. So let's say that we have got let's say one as one of the elements, we have got two as another element, and three as another element in one of the sets. So these are the first three natural numbers. All right. The next set B, let's assume that this set has got again, like three elements. But this time the elements are the first three even natural numbers. So what are the even natural numbers? They are like 10 is an even natural number. 324, right? So that's an even natural number. On the other hand, a negative of 5 is not an even natural number. So we'll just consider the first three even natural numbers over here. So 2 and 4 and 6, right? So let's assume that this is the set B. So we have got two collections of elements over here, set A and set B. Now let's write down on the right hand side panel over here the set of operations, the list of operations that we shall be doing. Correct? So the first operation that we shall be talking about is the union of sets, right? And the second one that we'll be talking about is called the intersection of sets. Now, what does union mean? Union means, like when you take the union of two sets, we shall get a new set, right? So you add two numbers, you get another number, right? So in the same way, if you take two sets and you take the union of these two sets, you will be getting one set, right? And this one set is going to contain all the elements of set A and set B, correct? And the second operation that we'll be talking about is called intersection. Now what happens in intersection is that we take intersection of two sets, again like union we get a new set. However, in the intersection of two sets, we will be finding the elements which are common to both sets A and B, right? So if we write A union B, that is the union of these two sets, right? So A union B. So the word union is represented by the symbol over here, right? So the symbol over here is the union, the symbol for union. It looks like a big U, correct? And the symbol for intersection on the other side is an inverted union symbol. So A intersection B is going to be written in this way, right? Okay, all right. Uh, so the symbol for intersection looks like this. Great. Let's now try to list down the elements of A union B, correct? So in order to do that, let's try to let's try to write down the elements of A and B in a tabular format, right? I mean, you can use bags, you can use, a football ground or a table tennis board. But what we really want to do is we want to separate the elements of A and the elements of B, right? So the elements of A, let's write down as 1, 2, 3, correct? And the elements of B as 2, 4, and 6. Now let's see if we have, let's now try to construct a set which contains elements from both of these sets, correct? So let's write down, the brace. all elements have to be written inside the second bracket, right? And then we have to separate them by commas, by using commas. So we start writing down. Okay, so before proceeding, we must remember that okay, let me write it down over here, right? So you have this box over here. The important part is that no no elements repeat, correct? So in a set, no elements repeat. So if there is an element, if you find another element which looks like the same, then you need to remove one of them. So there is no repetition in a set. So let's start with the elements of A. So in the right hand side bottom, you can see a box, and I have put a blue arrow over here pointing towards 1, which means that we are going to write down 1. Next, we have an arrow pointing towards 2, which also belongs to set A, right? So we'll write down 2 over here. Next, we see the element 3, right? So we write down the element 3. So you see, like we are just replicating the set A inside the set A union of B, right? So we have written on all the elements of set A inside the new set that we are constructing called A union B. Next, we move to the set B because we have already exhausted all the elements of set A. We will move to set B. So in set B, the first element on the right hand side panel in the right side bottom red box, you can see that I have put a blue arrow on the element 2, right? Now, if you see carefully, you have already written 2 in this union set of the union set of A and B. In A union B set, you have already mentioned 2. So we do not require to mention, we do not require to rewrite the element 2, and also it's not we are not allowed to write down the element 2 again, because it would result in repetition, and no elements repeat in a set, we know that, correct? So we are not going to write this element 2. Then we move to the element 4, which again in the right side bottom of your screen in the right panel, the second element, there is a blue arrow over here pointing towards the element 4 of set B. So we write down 4 because we have not yet written on 4 in this A union B set construction. Okay, let's now move to the last element of B, which is 6. Again, once we check the constructed set, we cannot find the element 6 over here. So we write down the element 6 over here. And then we discover that there are no new elements left. We close the bracket, and then we declare that, okay, the set A union B is going to be 1, 2, 3, 4, and 6, right? Okay, now let's move on to the set A intersection B. Now, as I said, as we mentioned that, just to revise what the operations we are going through, on the right side of the screen, I have put a bubble over there, and the union contains all elements, right? And as we had mentioned previously, the intersection contains all the common elements, right? So what we have to do, we need to check for each element of A whether it exists in set B, and for each element of B whether it exists in the set A, right? So and also, like, we need not do this both ways, because if we are checking for each of the elements of A and seeing that, if like if you are picking up one element of A and trying to find out in B, then like we'll exhaust all the possibilities that there might be a common element, right? I mean, it's not necessary that after checking for all the elements of A, we'll have to again go and check all the elements of B, because once that element, once we find an element of A already in B, it means that all the elements of B are taken care of. So we would, now, want to write down the elements of, the common elements of A and B. So, as per our, notation, we'll be putting an is equal to symbol and opening a new set. We are starting to construct a new set over here. This set is going to be the intersection of A and B. Okay, now let's check with okay, let's take up this red pen, and I'm going to put a star, a star beside element 1 in this, lower bottom panel on the right hand side. So the element 1 of A is being checked right now. So the element 1, if we find the element 1 in set B, we would declare element 1 as a common element of set A and B, right? Let's go for it and let's check whether, this element 1 is available as an element of set B. As you can see that, 1 is not equal to 2, it's not equal to 4, and it's not equal to 6 as well, right? So none of these comparisons work, and 1 is not an element of A intersection B. Okay, now let's move and let's move to the element 2. So I've moved the star on element 2. So you see, in when we are doing the union, we just saw a membership of of the element 1 in set A, and we introduced that element into our new set construction of A union B. However, when we are doing the intersection, we need to be careful to check whether that element is common to both the sets A and B. And hence, we will check for each of the elements in A whether it is also an element of set B. So in this case, in the case of 2 being the element of A, we see that there is a direct match of 2 in the set B, right? So we can declare immediately that, okay, the element 2 is common in both sets A and B. And once we declare that, we write it down in our set construction. The set construction, again, let me remind you, we are finding out the set of intersection of sets A and B. Again, intersection of two sets is going to be a set. The union of two sets is going to be is a set, as we have seen previously when we did the union of sets. So the intersection of A and B has one element 2 as of now. Now let's get a new star on 3. So 3 is an element of A. As we had mentioned previously, we are trying to find out for all the elements of A whether they are also elements of B or not. So we need to check whether 3 is an element of B or not. So 3 is not equal to 2, 3 is not equal to 4, and 3 is not equal to 6, which gives us that, okay, 3 is not there, it's not a common element. Now, once we have run through all the elements of A, we need not go and run through all the elements of B, which says that A intersection B is a set that contains only one element, that is 2, which means that the intersection of A and B is a singleton set. Okay, so having said that, we have demonstrated the operations union and intersection of two sets using an example. Thank you. Have a nice time ahead.